RCADT se complace en invitarlo a participar en el curso. Optimización holística de cadenas de transporte y logística. Las cadenas agroindustriales, o agroalimentarias, son un conjunto de actividades interconectadas que transforman materias primas agrícolas en productos finales para el consumidor, incluyendo la producción, procesamiento, distribución y comercialización. Estas cadenas son vitales para el sector, ya que añaden valor, generan empleo y contribuyen al desarrollo económico, aunque a menudo enfrentan desafíos para la inclusión de pequeños productores, que requieren la colaboración entre el sector público y el privado para superar barreras como la infraestructura y el acceso a crédito.
Operations research uses the scientific method to address organizational problems, focusing on providing management with a mathematical basis for decision-making. It is not a science, but more the application of science, logic, mathematics, statistics, and various theories to managerial and administrative problems. It focuses on organized systems, using interdisciplinary teams of scientists and engineers. Operational research began in 1937 in Britain and developed in countries such as Australia, Canada, France, and the United States. Structure. The group of courses aims to train the participant in the main problems that need to be solved in the planning and advanced programming of value chains specific to industrial engineering, and more generally to engineering. It is made up of 4 courses in applied operations research. Industrial supply chains. Agro-industrial supply chains. Demand chains, and transport and logistics chains. Courses can be taken all in a group or individually, depending on the student's interest. Optimization of agro-industrial supply chains. Training in the problem of agro-industrial supply chain optimization, focusing on optimizing decisions on how to optimally produce the products they offer. The course focuses on primary link optimization, farms and ranches, and its coordination with secondary link factories, value-added industries that use the animals and/or plants produced in the primary link. The following types of optimization models are studied: sowing and harvesting planning, farm network planning, feed sourcing planning and scheduling, harvesting of crops and animal cohorts, allocation of slaughtered animals to commercial products, available to promise, planning of seasons with super peaks of demand, synchronization of the primary link with the industrial link, and biomass energy generation. Aimed at professionals, engineers, mathematicians, physicists, consultants, economists, data scientists, software developers, etc., who require and/or wish to know mathematical modeling, advanced analytics algorithms, related, among others, to the implications of Industry 4.0 and its relationship with the process of evaluating the technical economic impact of the decisions that are made. This continuing education program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and/or supervise, with propriety, the professional functions in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of the companies. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives: training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Information technologies. Computer technologies correspond to the computer tools available, freely or commercially, to design and implement solutions to problems in social or industrial organizations. Specific objectives: learn how to implement solutions applied in the real world by making use of the modern computer technologies available for the algebraic modeling of industrial and business systems. Present and manage live tools used by large companies to solve their optimization problems. Understand the state-of-the-art of optimization and its relationship to smart computing. Know the available technologies, as the principle of basic knowledge to be able to solve, in reasonable times, problems with millions of variable. Know the fundamentals that must be had for the assembly of models using the most effective technologies. Value chain optimization or enterprise-wide optimization. Operations research uses the scientific method to address organizational problems, focusing on providing management with a mathematical basis for decision-making. It is not a science, but more the application of science, logic, mathematics, statistics, and various theories to managerial and administrative problems. It focuses on organized systems, using interdisciplinary teams of scientists and engineers. Operational research began in 1937 in Britain and developed in countries such as Australia, Canada, France, and the United States. I invite you to watch the video. Applied Operations Research and Industrial Engineering and learn more about AWO. A company's value chain is made up of two chains, strongly interrelated. Demand chain determines all the processes that are carried out to attract customers in the markets, and supply chain determines all the processes that are carried out to produce the products that customers want to consume. The diagram presents the chain of the company's production chains that together make up the value chain. One of the greatest evolutions in the modeling of companies occurs in the interpretation of their value chain. The diagram presents the evolution of different administrative practices in companies, which are linked to technological solutions, leading to AWO. Thanks to computational power, the integration process has continued to grow. The diagram presents the original S&OP model, and the current version, which integrates more and more models. This evolution has led to modeling based on artificial hypothalamus, supported by the integration of mathematical programming and artificial intelligence. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. Mathematical models for sales and operations planning. Planting planning, inventory optimization, optimal energy management, industrial link optimization, advanced demand modeling, projection of hydroclimatic variables, harvest planning and scheduling, food supply master plans, optimizing primary links, farms, integrated planning of the agro-industrial sector, animal cutting planning and scheduling, production and distribution of concentrated nutrients, and financial risk management in agro-industrial chains. The diagram presents the flow of models and data that must be taken into account in a typical agro-industrial chain. This process is summarized in the following activities: planning of the planting, or the birth of the animals, control of operations, and scheduling of the harvest or cohort harvest. The diagram presents the flow of models and data that must be taken into account in a typical agro-industrial chain. This process is summarized in the following activities: planning of the planting, or the birth of the animals, control of operations, and scheduling of the harvest or cohort harvest. Agro-industrial supply chains are divided into two links, which must be integrated to have an optimal planning of the production system. The primary link associated with farms, and the industrial link, linked to the factories that produce high value-added end products. Systems modeling starts from a prototype model that represents farms.
Se construyen todos los modelos matemáticos, para cada una de las granjas que integran el eslabón primario, y
the mathematical models are connected to the network of farms and industrial plants and are used to optimize the processing of raw materials from farms into commercial products in markets. The diagram presents an agribusiness in the pig sector. Plant-based product nets are similar to animal-based ones, but they have slight differences. The image presents a distribution network of plant-based products. The image presents a distribution network of products of animal origin. In short, to model each productive fabric, you must be aware that the differences make it impossible to have a generic model for the entire agribusiness sector. Some specific issues are discussed below. Primary link planning. The optimization of the biological and/or genetic processes that are carried out in the farms/ranches is carried out based on the simulation of the biological commercial cycle and the growth process due to the nutrients received, The models simulate the probabilistic development of any living species, in order to determine the decisions that maximize the utility of the business. To this end, the growth process is associated with the costs incurred as a result of the consumption of resources and the profits obtained as a result of the sale of products. Decisions such as advanced analytical technologies are used to optimize decisions in bio-industrial production chains, whether of plant or animal origin. Due to their similarities, the chains can be conceptualized generically and biological and/or genetic differences in the models can be respected. These chains are composed of two links: the primary, related to the processes of growth and/or reproduction on farms or ranches, and the industrial, which is carried out in industrial processing plants. Allocation of slaughtered animals to commercial products, available to promise planning. The use of animals to meet business commitments in an agro-industrial company involves a mathematical allocation problem that must coordinate farms, industrial plants, and committed orders. Since there are countless alternatives to convert living beings from farms into commercial products, whole animals and parts. To do this, it is necessary to start from the expected production on the farms, breed, type, weight, volume, and the conversion ratios of living beings into commercial products in accordance with their technical specifications. The goal is to maximize utility by meeting market demand. Supply of balanced feed or fertilizer. The problem of planning and scheduling the supply of balanced feed on farms. In plant chains, the supply will be of fertilizers, and the production of such food in multiple industrial plants is common in many agro-industrial companies, due to the horizontal integration of the production chains of living beings and their nutrients. To do this, a set of mathematical models is required to solve the following problems. The optimal supply of balanced feed considering the age distribution of living things on farms, including truck routing. The planning and scheduling of production in plants, including the mixing of raw materials, that depends on farm planning. Assigning production to customers, available to promise. The solution to this problem involves the design and implementation of mathematical optimization models that assign products to customers, considering bilateral supply contracts in detail, and schedule the shipment of orders in appropriate vehicles, considering long-term transport contracts. To model trading conditions, they must be converted into algebraic constraints. In many cases, the ATP problem involves designing and locating mobile packing plants on farms, according to the expected production on the farm lots. The course group director is the founder and executive director of RCADT. Engineer Velasquez Bermudez's experience in applied operations research dates back to 1972, which means that he has accumulated 50 years solving real-world problems doing engineering consulting using mathematical models.
La tabla presenta el plan de temas previsto para el módulo Optimización de cadenas agroindustriales.
RCADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information, you can consult the URL. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.